All right, hello everybody. How are you all doing? All good? Yeah, I'm not sure like if I can have lunch because I had like a really heavy breakfast, little late. Yeah, so I'm Manoj from Serverless Guru. So today I want to share with you 6 lessons, or maybe another one as well, if time permits, on how to process real-time feeds on AWS with high-throughput event feeds. So, all right, so in Serverless Guru, we are working with multiple type of customers. So we have enterprise customers, large enterprise customers, and also we have startup, and also we are working with non-profit organizations as well. Now, the lessons I'm going to share with you are coming from working with a large enterprise customer in Canada, and I designed and delivered 3 production applications that process millions of requests per hour, right? So if you're planning to build real-time processing applications, so you might learn a thing or two from this presentation. So let's get started. Now, before I want to discuss those 6 points, I would like to talk about a flash sale, because Luis also mentioned about a promotional flash sales. So I'd like to talk about that as well. Now, you all know what flash sales are? So during a flash sale, you get like lot of discounts, like 50% off, 60% off, but amount of time is like quite limited. So lots of people started jumping onto the offers and then get it. For example, let's say now you have a new iPhone release, right? So iPhone 17 is there and it's 50% off. So everyone wants to grab that deal, right? But as a customer, I quickly jump into that and then I grab the iPhone and put it into my cart. But then I realized, oh, look, I already have Samsung Galaxy S5. So should I buy it or not, right? So these are the things that in flash sales sometimes happen. So let's imagine now you join one of these e-commerce application or the company as an architect, right? And their business team says, all right, look, we need your help to send immediate notifications for our customers when they are doing their shopping. So I say, all right, good. So what sort of notifications are you interested about? So one of the urgent notifications that we really want is check out immediately. The very same thing that I just mentioned. So in case a person gets a notification, look, your cart is already sold. Although you just jump into the at cart, but you did not check out. While you are having your second thoughts, someone else came in and bought that product. So in this type of e-commerce application, your cart is not logged. So unless you really check out, you are not logged. So if you check out, then you get your item. So he says, because of that, lots of customers come and complain, okay, they couldn't actually get their product. So we want to do a kind of a user experience improvement in this product. So can you help? I said, of course, yes, I can. Then I have a question. So how am I going to understand this setup? So let's say during a flash sale, customer adds an item to a cart, and then he's not making the purchase, but now the stocks are going down, and I have to send a notification. Otherwise, like he's going to lose his cart. The business says, don't worry, we have business rules. I said, oh, I like business rules. So here are the business rules. So we have like 3 types of feeds. We have clickstream feeds. So clickstreams are all the feeds that when customers are interacting with the website that get generated. So if you receive 1 or more views on a particular product, let's say that iPhone 17, right? And that customer adds that iPhone 17 into his cart. So that's also get from the clickstream feed. Then you have to wait. If you get a payment succeed event, now you're getting it from the payment feed. If you don't receive it for the next 5 minutes, then you also receive low stock feed from the inventory feed. So in that case, you have to send a notification, hey, hurry up. Your product is almost sold out. Otherwise, you won't have that. So that's that. I said, okay, it makes sense. It looks like you need CEP. So the product is like, what is CEP? Oh, I'll tell you about CEP. So CEP about complex event processing. Now, these are 3 feeds, right? We have clickstream feeds, inventory feeds, and the payment feeds. Now, these feeds have different throughputs. Clickstream, obviously, because lots of people are interacting in the website. So you get like high throughput, 600 TPS. Do you guys know what TPS is? Transactions per second, like per second, how many requests or transactions or events we are receiving, right? And then the inventory feed. So inventory feed is little bit lesser than the clickstream because you get inventory up and down and those type of feeds you are receiving in the inventory feed. And then the payment feed, little bit lesser because not everybody is purchasing it. So let's say it's 100 TPS. So if you wanted to send notification as such before, so you have to correlate and analyze these feeds. So this is all about complex event processing. Because remember, these feeds are not always synchronized. So you have to synchronize them in order to do this, analysis, right? So it's CEP. So I said, all right, you need CEP. Okay. Now this is my lesson 1. So after that, I have a couple of workshop with the customer to understand the scheme of these feeds, and then I understand, all right, these are the technology stack I'm going to use. And when I start thinking about what is the technology I should use for my stream processing or getting my streamed, that's my lesson 1, choosing the right service. What do you all have to do? My suggestion is always start with serverless first, but not only serverless. So in this case, I want to have a stream processing service. So what do I have? So I'm going to start with my serverless first thinking. Okay, in AWS, I'm going to use AWS by the way. So in AWS, I can use Amazon Kinesis. So Amazon Kinesis is a cloud native service from AWS, and that is more than capable of handling real-time feeds. So that's good. So I can use that. Or I can use Amazon MSK. Have you all heard about Amazon, Kafka? Apache Kafka? Yeah, right? So that's the managed version of Apache Kafka. So you don't have to run that Apache Kafka by yourself. Amazon have a managed service that's called Amazon MSK. So I have these 2 services that I'm then thinking, okay, which one I should use for my stream processing. Then I get some additional information because I'm in the design phase, right? So the customer says, the business says, look, we already have MSK cluster. So in that case, there's no option, like I'm going to go ahead with MSK. And they also want some little bit of a fine-grained control about the brokers and all that. So if you are familiar with Amazon Kinesis and MSK, in MSK you have to set up some brokers and all that, but Kinesis, you only have to define the shards, number of shards that you have to use in your processing. So in that case, I'm going to go ahead and use Amazon MSK. All right, so next, so I chose the streaming service, Amazon MSK, I'm good. What about for the CEP? Now here, I have my opinion. I said, I'm going to go ahead with Amazon Apache Flink. Because I know Apache Flink is a lightning fast service that you can do real-time analysis and processing, and you can boost up the parallelism and all that however you want. So it's a really good service. And in fact, the services like Netflix, Uber, they all uses it. So I'm going to go ahead with Apache Flink. So I'm decided on the technology stack because I also know these streams have different throughputs. And if I wanted to do some correlations, I have to do stateful processing as well. So Apache Flink supports that, right? And parallel processing, it supports. And I can tweak, right? All right, so I decided on Apache Flink. So the next question is, how am I going to run Apache Flink? Am I going to run Apache Flink on ECS or EKS in containers? Or am I going to use one of their managed service, Amazon Managed Flink? What do you all think my decision is? Amazon Managed Flink. Guys, I really think we are taking these managed services for granted. Because I can share one of my experience, right? So when I joined with this enterprise customer, at the beginning, I was assigned task to upgrade the version of their MSK cluster, right? So this cluster, they are running lots of production application. So as someone who joins the organization and then given a task like that, I'm a little bit reluctant because what if something happens? Because these guys are processing feeds all the time. There's no any low traffic time, right? But then again, we are using MSK, Amazon Managed MSK, right? So I did a little bit of research about the documentation. It says, all right, how many brokers do you have? I have 3 brokers. How many brokers should I have in sync? Only 2. So that gives me a little bit of a release because when Amazon MSK is doing a version upgrade, what it does is it pull out one broker and upgrade it version and plug it back to the cluster. So as long as I have 2, I need only 2 brokers to be in sync, I'm good. And there were a couple other things. Is your CPU is below this rate, below this level? Go ahead and do it. So all the criteria met. So I just went there and then clicked that button with the DevOps, and look, it was butter smooth, and then my cluster was running the versions that I had. So it's all about peace of mind, right? So when you deploy your application to production, you have to make sure that you have peace of mind. Otherwise, 2 a.m. calls and all that, comes in. So managed service really provides that. So I think we all should think about managed service as our default, first to think, unless we can't use them, right? All right, so I'm going to go ahead with the Amazon Managed Flink. Now, design so far. So I have these 3 types of feeds: clickstream feeds, inventory feeds, payment feeds, coming in different throughputs, and I'm getting them into the Amazon MSK topics. So I'm absorbing them. And Amazon MSK topics are really capable of handling high throughput feed. So check, what's the check mark? High throughput, real-time pre-processing. It has the check mark. It's good to go. And then I have Flink application who's consuming from these feeds and do all whatever the analysis it needs. It could be that the initial processing I've been talking about, or it could be any other use cases, right? It's able to handle that real-time analysis part. And once it analyzed, and once it detected that immediate checkout events, then it will push into another MSK topic so that my consumers are able to consume those events and then send notification. So up to this part, I'm all good. So now I get all events that Amazon Flink identified as checkout immediately into this Amazon MSK topic. So how am I going to proceed with this? Now I need some consumers to consume these events and send notification. So what other options do I have? All right, so I have a couple of options. Now, gladly, I found this really good benchmarking. It's a little bit outdated, but it's really still true. So it's about how scalable these different services are. Starting with Lambda, you can see on the leftmost corner, what they did is they try to have 3,500 concurrent containers and running in these different type of services. On your left, you have Lambda. You can see immediately it got up to 3,000. So that's like the burst concurrency, right? So Lambda, depending upon the region, you have burst concurrency like 3,000, and after that you see there's a little bit of a time, still again millisecond to get another 500. So earlier it was 60 seconds, so it takes another 60 seconds to get another 500 concurrent containers, but now they even reduce it to 10 seconds. So Lambda is ideal for handling burst traffic, right? Because as Luis mentioned, right? So when there's a promotion, everybody's clicking that refresh icon. You get a burst of traffic. So you need some service that can scale as fast as it can, right? So there's Lambda, and if you think about the others, you have ECS on Fargate, the orange color one, EKS on Fargate, EKS on EC2, ECS on EC2. So it takes a little bit of time to handle that high throughput feed. But does that mean we should always use Lambda? No, because Lambda, it's only processing one request at a time, right? But you can have your containers that is running on Fargate or EKS, right? That can get more requests and process them. But in our situation, in this particular use case, you can't actually predict how much traffic that you can get. And this is a huge e-commerce application, and there will be multiple flash sales as well. So in those cases, we would go ahead with Lambda because it can handle our throughput. There we go. All right, so I plug in Lambda. Just by dropping Lambda, will I achieve the throughput I require? What do you all think? No. And that's why the second lesson. So it's about choosing the right partitioning strategy. Now I just zoom into that output topic. The Flink send those messages into this output topic. So when Flink is sending these messages, in each MSK topic, we have partitions. So if you are using Kinesis, you have shards. So messages are pushed into the shard, and MSK topics, messages are pushed into the partitions, right? So if you want to have the throughput required, Lambdas to have high throughput, you have to make sure your partitions numbers are correctly set up. Because in Lambda, it's always consuming from one partition in parallel. So let's say I have 3 partitions, then you can get maximum of 3 concurrent Lambda running, right? So In each partition, it can process the batch of messages, 100 messages, 100 messages, 100 messages. So if you are having 3 partitions and these lambdas are processing these messages within 1 second, you can get 300 TPS here, right? But if you need more than that, or if your lambdas is taking more time to process it, you need to have like more partitions, right? But then again, there are few nuances, right? When you are sending the messages, you should not push into the same topic, like hot partition should not be there. So it's like a little bit of outside of this presentation scope. So you always have to think about the partitioning and the batch size, all right? So with that, what do we have? So we have a lambda, tick. What does that mean? So lambdas are able to handle that high throughput processing. Now what about the lambda? Okay, it can send the messages. It should also maybe persisting into a database or something. So how are you going to make that layer high throughput, able to handle high throughput? So that's where, this is number 3, you have to manage downstream connections. So that's where you need to leverage connection pooling and bulk processing. Let me talk about that one. Now our lambdas are able to like handle high throughput. Now it's, let's say now it needs to persist all these messages into an RDS table, or it could be into an OpenSearch cluster, right? So if you are just sending all that traffic to Amazon RDS or OpenSearch cluster, maybe in the Amazon RDS, the instance that you chose does not support that many connections, right? There could be a connection exceed error, right? So what can we do? Will RDS proxy helps here? Let's see. Yes, it does, right? So how is it going to help it? Because if you put RDS proxy in front of RDS, right, you get that database side connection pooling. Right? But just that is not enough. Of course, at the database level, it will try to reuse the connection. But at the lambda level also, you have to have some connection pooling going, right? So you have to make sure your lambdas are doing connection pooling as well. So if you have both of these, there's one other additional option that can really help you with the number of messages or the number of requests. That's about using bulk APIs or bulk queries. So if you're writing to OpenSearch, probably you should use bulk APIs, right? Because that's less number of requests. So these are the options. Now, what do you guys think? Like, should I add a queue in between that? What do you all think? Will that help? If I add a queue right here, what do you think? Well, look, it obviously it can help, but if you really think about it, right? What does queue do? It keeps the messages for a kind of a transient storage. It keep the messages, and the consumers are consuming from that, right? So you want to like reduce the throughput, but you can do it with your MSK topic as well. If you are correctly defining your partitions, and your lambdas are now processing it, the partition can have a little bit of lag. That's all right, right? Because as long as you are managing the number of messages, number of the connections or number of messages that is processed, you can use the partition itself. You don't have to introduce another service just because like it's widely known to like reduce the the throughput, right? Because what happens when you add a new service? It's introducing another latency. That's an additional hop, right? And in our case, we want to reduce the latency as much as possible because we are processing high throughput feeds. So in this case, probably it might not work, but in other case, it can, right? All right. So lesson number 4. So it's about idempotency for exactly once processing. It's about duplicate messages, guys. Now, when you are working with real-time feeds, right, you always get a duplicate message. I mean, not right away, but at some point in time, you get a duplicate message. So how these duplicate messages are introduced? For example, let's say downstream service is not working for some reason, and now you have to like do a replay of these events, right? So in that case, the same message needs to be processed, right? Yeah, I mean, for some reason, you can get a duplicate message, and your architecture should not send multiple messages to the customer just because of that duplicate message. You always have to have idempotency checks, right? Now, there are two concepts. Now, there are services like, let's say, FIFO SQ, and standard step function that says that it does only exactly once processing. Even the Flink you can configure to send only exactly one messages to the MSK topic, right? But the problem is, guys, the exactly once processing is scoped to that particular service. Whenever you are tagging along another service like Lambda, this is a distributed service, right? So this is a distributed service, this is a distributed service. There's always a chance that a duplicate message can be introduced. So we had actually this problem, right? So while we were working, we saw we are processing the same message in two different partitions. It's the same offset. It can't happen, right? Theoretically, it can't happen, but we are getting it. So we connected with the AWS and all that. So what they recommend is this can happen, like however seldom. So it's always recommended to have a idempotency table. So in this case, like you can use DynamoDB for idempotency table or any other case. So you can use like conditional expressions. So before you are writing to the notification service, you put idempotency key and you use like message. There's these conditions, right? A message exists, not exists. Those conditions. Those are atomic expressions, right? They work in atomic manner. So even like concurrently, two lambdas are writing to DynamoDB the same message. That won't. I mean, it's okay because they only be processed as like in an atomic manner. And someone might think, is this going to introduce a little bit more latency? Little bit, because you see, it's just a get item query. What is less, single digit millisecond, but it would give you like lots of value, right? So always think about idempotency. So my suggestion is, without targeting for exactly once processing, let's target for at least once processing with idempotence, right? If you are serious about handling high throughput feeds in a low latency manner. Because you see now, if you are using exactly once processing, the throughput limits are also a little bit reduced in service to service, right? Okay, lesson number 5, the poison pill. Now you always get one of that as well, the bad message, right? You always get a bad message. Now, trust me, if you are developing a stream processing application, you always get a bad message. So when that bad message is received, if your system breaks, if your architecture breaks, that's a big problem. So you always have to handle that poison pill. So how are you going to handle it? So in this case, let's say now you are getting a one bad message in partition number 1, right? So the Lambda try to process it, it can't. So it throws an error. So it's the same batch. Let's say one of the messages in that batch has a bad message and it can't process it. So Lambda throws it. So same batch goes back to the MSK cluster in that particular partition. So we are again Lambda is polling the same batch. You have the same issue. It's a vicious cycle. So that partition is never being processed. So when you are developing applications like real-time processing, you should never block the continuous processing. So what you should do instead, you can do some retry logic with exponential backoffs and then push it to a DLQ or something. Now, this might also have some little bit of concerns, particularly like when you have parallel Lambda functions are working, right? Again, it's a little bit outside the scope of this presentation. So you might have to think about token bucket implementation with the DynamoDB and all that, right? But here, for this presentation, you can think about like always use exponential backoffs and retries and never block the continuous processing. All right. Last lesson. So observability is your radar, right? So once you're on production, how do you know your data processing application or the architecture is working fine? You always have to have really good observability tracking with monitoring and alerts. But what I've seen is, whenever we think about monitoring alerts, people start setting alarms for every metrics. It's just a noise, like you get like so many messages and so many alerts and just noise, right? So you need to think about what all like really important matrices that you should track. Now in this case, so we have that clickstream processing Lambda, and Amazon Flink is now consuming it. So Amazon Flink is a consumer of that messages, right? So if Amazon Flink cannot match with the feed throughput, there will be a lag building up. There will be lots of messages staying in that particular partition that is not processed. So how do you monitor it? You have to think about CEP lag or the offset lag for that Amazon Flink. Similarly, once Amazon Flink push it to the output topic, the Lambda, if they can't like process the same throughput, there will be a lag will be built here. So you need to think about having a consumer or the offset lag for the Lambda as well, right? And then if at least one message is sent to the DLQ just because of a bad message or whatever, you need to look at it, right? Because that's something that you are not sending to the customers. That's a missing notification. So you have to like have a alert for at least one message is sent to the DLQ. You should have an alert trigger, right? So these are like some common alerts that you should set up in your data processing architectures. And of course, Lambda errors and all that, you should have some alerts. Now, yeah, so these are the 6 lessons I want to share with you. So if I reiterate it again, you always start with serverless first, but it doesn't mean not only serverless, right? And then you have to think about the partition strategy, right? If you are really concerned about processing them in a high throughput manner, and the leverage connection pooling without killing your downstream, right? And then duplicate notification handling with idempotency table and all that, handle the bad message, the poison pill, and having a good observability pattern, right? So these are the 6 lessons I'd like to share with you today. Yeah, I'm on time. So I only have 1 minute left. So yeah, so thank you. I don't think I have time to share the other 2 lessons, because at the beginning, I had 8 lessons, but I know I can't cram all that 8 into 30 minutes presentation. Yeah, just talk to me. I'll be waiting outside if you want to discuss more about real-time event processing. Just talk to me, guys. I'll be happy to help. And also, if you want to connect with me, you can find me on LinkedIn and on YouTube, on Udemy, wherever you can find me. Thank you so much.